See, the complex number can be denoted by, once again, all of you observe here, Z. So Z is equal to x plus iota y or a plus iota times of b. So I told you clearly A is called, what is A here?
Real part.
RE, real part of Z can be written as RE of Z. RE of Z nothing but real part. Real part of Z. So this real part of Z simply we can written as RE Z. What about B? I M Z. That is nothing but imaginary part. Imaginary part of Z. So I am Z. Okay. Right. So every complex number we can express as a plus iota times of b, nothing but the sum of the real and imaginary part. Real and imaginary part. Remember that. Okay. And since here we know that when I take here Z conjugate, Z conjugate can be denoted by Z bar. So we can call it as Z conjugate. This is A minus iota times of B. So when I adding these two values, so then what about here, student? Iota times of B
Get cancelled.
get cancelled. So shall I write Z
Z1
plus
plus Z2 equal to 2A.
2A, which implies A can be written as Z plus Z conjugate all divided by 2. Is it
Sir,
clear?
arithmetic mean of the both ones.
Yes.
Sir,
Yes,
A
sir.
is equal to arithmetic mean of the Z and Z.
Exactly. So anyhow, so I'm going to find here the real part of Z. So real part of Z can be written as Z plus Z bar by 2 arithmetic mean. Okay, anyhow. So this is A nothing but real part of Z. So this is important, student, remember. So RE of Z, any complex number. Real part of any complex number is given by sum of the given number, its conjugate, all divided by 2. In the same way, can you tell me what is B? Imaginary part I want to find. For that, what shall we do here? A plus iota times of,
Subtract the
exactly.
equations.
Exactly. A minus iota times of B. So when we subtract here, minus plus. So then here Z minus Z conjugate is equal to 2 times of iota B. But I required only B, not iota B, only B. So B is equal to Z minus Z conjugate all divided by 2 into iota. Is it clear? So this is B is called imaginary part of Z. So imaginary part of Z always is given by Z minus Z bar by 2i. Here it just real part only 2. Here 2i, remember student, real part, imaginary part. So objective point of view, it is important. Real part, imaginary part. So remember that. Okay. So right. See, every complex number can be written as A plus iota times of B, real part plus imaginary part. Okay. Real part, sum of the real and imaginary. That you have to remember. For example, because they may give few numbers like complex numbers, and they may ask to change the standard form. For example, minus 1 by 2 I into like 3 by 4 into iota, they may ask. So now they may ask change to standard form. What is the standard form of this complex
Sir,
number?
can I stop previous one, sir?
Yeah.
Okay, sir.
Sir,
You
we
can
can
stop.
put everything into iota, sir. It is in
Yeah.
the form of A into B into A into C, sir.
So yeah. See here, in this case, we can multiply directly. Minus 1 by 2 into 3 by 4 value is what? minus 3 by 8. Yes or no?
Yes, sir.
I into iota
sir.
into iota square.
Minus 1.
So minus 3 by 8 into iota square value is minus
Minus 1.
1. Remember students, iota square till iota power 4. Iota is equal to iota, then iota square is minus 1, and iota cube is minus iota. Iota power 4 is
Plus
plus
1.
1.
One.
Until we are getting 1, we can uh, increase the powers. So finally, what is the answer here? 3 by 8.
3 by 8.
Okay, 3 by 8. That's all. So this, but is it in standard form?
No,
Standard
sir.
form in nothing but. So
3 by
standard
8
form
plus
means,
I
0 i.
plus I into 0 iota.
yeah, 0 iota, exactly. So like that, you have to express in standard form. Okay, so now we can easily find this is equal to 3 by 8 plus 0 times of iota. You should write in standard form. So which implies now, tell me what is the real part comparing with a plus iota times sub b. So a
Sir,
is equal to 3 by
B is equal to 0.
b is equal to 0. Nothing but you should write like this. Real re of z. Real part of z is equal to 3 by 8. Im of z is equal to 0. You should write like this. If they ask real part and imaginary part, first you have to change it to standard form like that. Okay, my question is 0 is a complex number or only real number?
So complex number also.
That can be expressed.
0 plus 0 i.
0 plus 0, absolutely right. See here, every number is a complex number. See, every number is need not be a real number, but every number you can take. This is the largest number system. Okay, this is the only large. You can take any number.
Sir, we can
Yes,
also say real number is the subset of complex numbers, sir.
yeah,
So
we can
every
write.
real number is a complex number, sir. So 0 is a complex number.
Yeah,
Sir, all
Sir,
real
but you
numbers are
said
complex. Sir.
all real number is complex, but all complex number may not be real number. Okay,
Okay,
so
sir.
that we can write like this. So that if we say, if we take here uh, yeah, yeah. First, this is a natural number. Then next, this is integers. Next, this is a real number. Finally,
Complex number.
complex number. Okay.
sir, you said a comma b is real, no sir?
Yeah, a comma b always real.
Sir, so if a comma b is irrational, then it will not be a complex number, sir.
So why not? Every irrational number is a complex number. Irrational number is also a real number, no? Every real number
Yes, sir.
is subset to, yeah. So here, first the number system is natural number. Next, yes, this is natural number. Next, this is integers. Next, real number. Finally, complex number. So n subset to integer subset to real number and subset to complex number. We even in between you can take whole numbers also. Okay, like that you have to remember, students.
Sir, which symbol represents imaginary numbers, sir?
Iota.
Iota.
Yes, sir.
That's it. Iota. Okay, iota is equal to square root of -1. Still, is it clear, friends? So here I'm going to explain you that inverse of a complex number. See, students, here can you tell me z is equal to a plus iota times of b? Okay, all of you concentrate here. It is very, very interesting, very, very easy. So if you concentrate and if you understood, it is the very difficult. I told you one of the difficult one, objective point of view. If you understood basics very clearly, it is very, very easy. So this is Z. Z conjugate is equal to A minus iota times of B. That you know that. What is the modulus of Z generally? Square root of?
4a
Square
Root
root
of
of
a
a square
square
plus
plus
b
b.
square.
a square.
Okay. Can you find Z into Z conjugate? Z is A plus iota times of B. Am I right? Z conjugate is A minus iota times of B. It is in the form of
A
A
plus
plus
b
B
into
A
into.
a
plus b
minus
into
b.
a minus b.
Shall I write
A
here?
square plus b.
Yeah. Shall I write like this? Okay. Now,
Sir, we can
So
write
we can
iota
write
square.
it as a square plus b square, sir.
yeah, A square plus B square. Before that, I'm writing. So now, iota square is minus 1 minus into minus plus. So, okay, we can write
A
A
square.
square plus B. Okay. Now, if I squaring on both sides this, modulus Z is equal to root over. If I squaring on both sides, shall I write like this? A square plus B square?
No, sir, plus or minus a square plus b.
No. Why? If we having modulus some x square is equal to some a square, x square is equal to a square. Now x is equal to, we can write plus or minus a, but when we squaring, plus or minus becomes plus only always. I squared here.
Okay.
Why you want to plus or minus? Okay, no, it's not plus or minus, just plus always. Okay, so left side is z into z conjugate. We got as a square plus b square. What is a square plus b square value? Shall I write modulus? Is it clear? Z into z conjugate is what?
Modulus z square.
Yeah, remember this. This is one of the important property actually. Z into z conjugate always is equal to modulus z the whole square. Okay. So when we observe the modulus properties, here first property that modulus z1 into z2 can be written as first. Let us see the conjugate properties. Z1 plus Z2 all conjugate can be written as Z1 conjugate, Z1 conjugate plus Z2 conjugate. And the second point, Z1 by Z2, it may be minus also. Z1 by Z2 all conjugate can be written as Z1 conjugate by Z2 conjugate. Okay. And third property, Z1 into Z2 all conjugate can be written as Z1 conjugate into Z2 conjugate. These are the simple properties. Here, Z2 should not equal to 0. Z2 should not equal to 0. So not only that, even you can take modulus also. Modulus that we will see that this uh, modulus
Sir,
properties.
sir,
Yeah,
but that one can be 0, sir.
Z1
Can be
can
0.
be 0. 0. If yz2 cannot be 0 means, if it is 0, what will happen? It will become
Not
infinity, not defined. So that always denominator values itself, we are not taking 0. Numerator might be 0. 0 is a always complex numbers. Is it clear? So the exercise questions are very, very easy, students.
So 1 minute you show that slide, sir, that properties.
Yeah. This again, I'll explain all the properties here. Just I have written 3 here. We have nearly 30, 40 properties are there. All properties will discuss in OBT.
So what is the third property, sir?
Third property is Z1 into Z2 all conjugate is equal to Z1 conjugate into Z2 conjugate. We'll write separately that conjugate. Now all the properties we have done the same thing, you know. All conjugate we have written. So conjugate of each other.
Okay, sir.
Simple properties. Okay. Yeah, for example, sometimes what they may ask, here any complex number, it is in the form of like z is equal to, okay, 1 by a plus iota times of b is there. Is it a standard form? No. Standard form means always should be a plus iota times of b, not 1 by something. So how can you change to this is in complex form,
Sir,
standard form?
multiply by a into a minus.
A into a minus c.
Exactly. Multiply and dividing with a minus iota times of b. Nothing but you have to rationalize. When we rationalize, numerator is a minus iota times of b by again denominator in the form of a plus
Whole
b
square
into
plus
a
b
minus
square.
a square
Modulus of
plus b
z
square.
whole square.
Yeah. So here, uh, so okay, fine. Sure. If I take here the question itself, I'm taking z is equal to a plus iota times of b. Then this 1 by a plus iota times of b becomes 1 by z. Okay. Shall I take here 1 by z? 1 by z in the nothing but we can represent as z inverse. 1 by z, any number you can take 1 by 2 can be written as 2 inverse. 1 by x can be written as x inverse. In the same way, z inverse is equal to nothing but inverse of a complex number. How can you change the inverse of a complex number into standard form? Like z inverse means 1 by z, 1 by a plus iota times b. I rationalize. So here we getting like this.
Sir,
Now, yeah,
so if 1 by z equal to 1 by a plus iota b, then z equal to a plus iota b only also.
z is z is equal to, but I want to find 1 by z value, not z value. 1 by z I want to know in standard form.
Okay, sir.
Okay. Here I am finding 1 by z. I am changing 1 by z in terms of a plus iota times of b. So finally we got like this. So after writing like this, you have to write uh, real part separate, imaginary part separate. What is the real part here? A by a square plus b square plus iota times of what is the imaginary part? Minus b by a square plus b square. Like that, so try to write after simplifying real part separately, imaginary part separately. Understood? This is the real part, this is the imaginary part. So inverse of any complex number, if you remember this formula, you can write directly the inverse of a complex number in standard form. Otherwise, simply rationalize. In NCERT, you cannot write directly the answer. You must be rationalize. Okay, then only you'll get the marks. Okay, let us go for the exercise here. Yeah, these are the properties actually that we will discuss. Questions are very easy. Here itself, yeah, you only tell me what is the answer for this. Write
Yes,
EC.
sir.
Express each of the complex number given in the exercise 1 to 10 in the form of a plus iota times of b. Right? Tell me answer.
So first one is 3, sir.
Plus
Shall I
3, sir. Plus
3
shall I
3
plus
plus
0 y.
0 iota. 3 plus 0 iota.
Yes, so this is equal to minus 3 times of iota square minus 3 times of minus 1, that is equal to 3. You should not write 3 plus 0 into iota. You must be right like this. So after writing this, you have to comparing this with a plus iota times of b. Okay, that's all. Clear it is in the
Sir,
form of
should
a
take
plus.
and write that real part and imaginary part for this, sir.
Yes, sorry.
Sir, should we take the real part and imaginary part and write in the answer separately?
Your wish,
Okay, sir.
your wish. Because it's here, they give an imaginary part here, imaginary part, but multiplication is there here, multiplication. Okay, this imaginary, see there are two complex number actually. One is 5 into I, another complex number is minus 3 by 5 into A. Product becomes here, but they given only imaginary part here. Is there a real part in these two complex number? No, just imaginary part. The product of any two imaginary part always becomes real. like that. Okay, right. Now, anyone answer for
0, sir.
Zero,
here?
zero. Zero plus zero.
Okay, so how can you write here first?
Sir,
Sir,
I power
I
8
power
into I.
8 into I, sir,
Yeah,
plus
I power 16
I
into
power
I.
16 into I cube.
I cube.
okay. I power 16
16
into
into I.
I cube.
I
So this is equal to
which is equal to
I.
I plus minus I, sir.
Yes, yes. I power. We can write like, see here. Only the thing is, in NCRT we try to write more number of steps, so that you should write like this: I power 4, the even 8 also whole square into I plus I power 16. You can write I power 4 whole
Whole
power
power 4
4 into
into I cube.
I cube. I cube we can write
Minus I.
minus I. So like that, since again after that you can write, since I power 4 is equal to 1, then you can write 1 into 1
Since
square
I
into
power
I,
4 n equal to 1, we can write as I plus I cube, which is equal to 0.
which is 0. And 0 also, 0 plus iota times of 0. Don't write simply 0 and don't left. You must be right in a plus iota times of b in this form at last. So this is a required complex number, like that you have to write. Then what about this?
Zero.
Yes,
Sir, infinite. Single zero coming, sir.
this is I power, look at here, I power minus
Sir,
39.
I power minus 40 into I.
Okay, you should write like this. Why don't you write this is equal to 1 by I power, multiply and dividing with I power 39, no? Multiply and dividing with I. Isn't it? It is easy. I power 40. I power 40 can be written as I power 4 whole power 10. I by 1 power 10. Nothing but I by 1 is equal to I. But this you should not write only I, 0 plus iota. Clear? We can write in 2-3 ways. Yeah, as you said, I power minus 39 can be written as I power minus 40 plus 1 minus 1. I power minus 40 into I power minus 40 we can write as I power 4 whole power minus 10. Okay, it's up to
So
you.
1 minute, can you scroll up?
Sure. So these first 3 questions are easy, so that I have written here only. Take the screenshot or else take it.
Okay, sir.
It's better. Any doubts, students, in first 3 questions?
The third question alone can you explain?
Third question, why not? Third question is what?
I power
Right.
minus 13.
Minus 39. Okay, that, see, yeah,
Sir, can you simplify by using I power 36 into I power 3, sir?
you can simplify. You can. Anyhow, answer should be correct. That generally the proper steps is that it's better to write in positive power, like minus 39 is there. You can write plus 39. As you said, sir, you asked no 36. Yes, you can write 39 can be written as I power 36 into I power 3. Okay, I power 36 is multiple of 4. Okay, that is 4 all to the power of 9. Is it okay? I power 36 I have written like this. And what is I cube, Amma? I cube
Sir, minus I.
minus I. Okay, I square into, you can write I also, even if you write again more number of steps. So 1 to the power of 9 into I square is minus 1 into iota. So this is 1 by minus 1. Minus 1 will get, because minus becomes here. 1 to the power of 9 is 1 only. So finally minus 1 by iota. So again, it is not a standard form. For that, what shall we do? Rationalize, multiplying, dividing with iota. So what about the numerator? Minus 1 into Iota
minus
minus iota by iota square. Okay, so minus iota by iota square value is
minus 1.
minus 1. Minus minus get cancelled. Then this is equal to what? Iota. So iota power minus 39 in standard form a plus iota b can be written as 0 plus iota. Okay, you can write either multiply dividing with iota directly. Say I directly multiply dividing with iota here. Either you can do like this or else you can write I power 36 into I cube. That's up to you. Clear? Is it clear till question number 3? Yeah, in each and every question you only solve. Tell me answer for 4th question. Fastly. All are very easy. See here in question number 9 you can apply a plus b whole cube. Question number 10 you can take minus common, again apply a plus b whole cube. Okay, this is also multiply with 3 here, multiply with iota here. Do all the problem till question number 14.
Sir, fourth question we can write 3 plus iota into 7 plus iota 7. No, sir.
3 plus
Iota
what?
into 7 plus iota 7.
Are you saying answer?
No, sir. Next step.
Yeah. Simplify and tell me answer fastly.
Sir, can you show that solution for third one, sir?
Okay, right.
Okay, sir.
So instead of taking common here, so you are saying that 7 plus iota into 7 is common. Not required. You can multiply directly. After that
14
also,
plus 28 iota, sir.
answer is 14 plus
28 iota.
28 iota. Maybe, may or may. Yeah, remaining students, all of you check it whether it is correct or
Sir,
not.
same answer, sir.
Sir, correct.
Correct means you can go for next question. Don't wait. So we have to complete all 14 questions in this class. Let us see now. Do it fast, remaining question also. So 21 plus 21 iota plus 7 iota plus 7 iota square. 21 plus these two are 28 iota plus 7 times of minus 1. This is equal to 14 plus 28 iota. Absolutely right. Now 5th question.
Sir, 2 minus 7 iota.
Yeah, we can write directly. See here. When we multiply 1 minus iota, multiply with minus into minus plus 1 minus iota 6. That is equal to 2 minus 7 iota. Is it clear? Fifth one is simple question. Fifth one is very simple. Multiply with minus 1 plus 1 2 minus iota minus 6 iota minus 7 iota. That's very easy. Now coming to here, see this kind of this type of question, you can write real part at one place, imaginary part at another place. That's all. Okay, I'm giving one question. Instead of doing 6th question, all of you do the 7th one. Tell me answer.
Sir,
Fast,
going
7th.
to complete the 6th one.
Yeah, complete and do the 7th one. 1 by 3 plus iota times of 7 by 3. Plus 4 plus iota times of 1 by 3. Anyone
Sir,
got the
sir, 6th one answer is minus 19 by 5 minus 21 iota by 10.
Okay, fine. Once check the book back answer. Correct or not?
The seventh one answer is 17 by 3 plus I into 5 by 3.
17 by 3 plus iota times of
5 by 3.
5 by 3. Yeah, all of you check it, Amma. First, you have to simplify first two terms like 1 by 3, or else you can do directly also. First, you have to multiply with minus here. So 1 by 3 plus iota times of 7 by 3 plus 4 plus iota into 1 by 3 plus 4 by 3 minus iota. Now you can write real part at 1 place, 1 by 3 plus 4 plus 4 by 3 at 1 place. All real part at 1 place. Iota is common. Imaginary part 7 by 3 here. Remaining plus 1 by 3 minus 1. Now simplify this. Is it difficult to simplify? Take LCM. What is LCM? LCM is 3. 1 plus 12 plus 4 plus
Sir,
iota times of
the answer is 17 by 3 plus 5 iota by 3.
17 by 3 plus iota times of
5 iota by 3.
right. Absolutely right. The answer. So yes, simplify this. 17 by 3 plus iota times of 7 plus 1 8, 8 minus 3 5 by 3. Is that clear, students? First, whenever you want to simplify, you can write all real part at one place, all imaginary part at other place. Okay, then you can simplify real part, imaginary part, will get the required the complex number in the form of a plus iota times of b. That's all. That's fine. See, how can you simplify this eighth question? This is my
Sir,
because
1
okay.
Sir, 1 by I power I whole square into 1 by into 1 minus I square whole square.
Okay, very good. 1 minus
Sir,
iota
or you
whole.
can apply binomial theorem to find fourth power.
Why that is lengthy? It's not necessary. So see, Amma, yes,
formula itself will come for 2 lines, sir, if we take binomial theorem.
yeah, but you have to simplify, at least 3 to 4 terms. So this kind of, for example, 1 minus I power 4 is there. I want to take 40. Can you? Do you know what is a minus b whole power 40 formula? We don't know.
A
What
power
shall we
40
do?
plus b power 40 plus a power 39 b power
That
1.
is again very lengthy. Do you know again what
Sir,
is
we need to find coefficients for that everything. Sir.
this kind of question? I will tell you. Even it is OBT also. First, you should write 1 minus iota whole square whole to the power of 20. Actually, the given question whole power 4 only. I am taking 40. I am going to simplify. First, you can take whatever the power is there. If it is multiple of 2, first you should write square. Whole square whole power 20. Now, apply the a minus b whole square formula. A minus b whole square formula. What is the formula of a minus b whole square? A square plus b square minus
2ab.
2ab iota whole power 20 as it is. I applied a minus b whole square formula. Now this is equal to clearly 1 square is 1, iota square is minus 1, minus 2 into iota whole to the power of 20.
Sir,
So
minus 2 iota the whole power 20.
yeah, minus 2 into iota whole power 20. So this can be written as minus 2 whole power 20 and iota whole power 20. Can I write? Yes, we can write. So minus 2 whole power 20 becomes 2 power 20 because power is even power. No, even power means minus become plus. But what is I power 20?
0.
I power 20 0 now.
No, sir, 1.
Is it 0? It is 1 because
1.
I power 20 multiply 4 whole power 5. That is 1 power 5. That is 1. Okay. So is it a required complex number? Isn't it standard form? No. 2
No,
power
sir.
20
Sir, we
plus
can do 2 power 10 the whole power 2, sir.
Yeah, 1024 whole power 2. Yeah.
Ocean
Anyhow,
right?
you can, it is a large number, no? Large number you can write as it is. Okay, then 0 into iota. This is the required answer. For this whole power 40, but question is just whole power 4, you can write it. In the same manner, try to do remaining questions. All are very easy. Here a plus b whole cube formula that you know very well. Here also take minus common, and here also what they are asking, multiplicative inverse. Inverse means 1 by 4 minus 3 iota value they are asking. You rationalize 4
Sir,
plus
1 minute
3.
can you show the page, sir, in code?
Yeah.
Okay, sir.
Sir, can you show fifth one, sir?
Fifth one. Yes, friends, I have written something here. Is it right? Then final I square is equal to plus 1. Yes or no? Iota square can be written iota into iota. Root over minus 1, root over minus. Since we know that it can be written as minus 1 into minus 1. So minus into minus plus 1. Plus 1 means it will be plus 1. Is it right?
No, sir.
Sir,
Why?
we
No,
cannot
sir.
multiply the square root.
Since we know that iota square value is minus 1. But as I done this procedure, is it right or wrong? If it is wrong,
Wrong, sir.
where it is wrong?
Sir, second
The
step is the
root, yes, the
Sir,
root
root
of
cannot
I
be
or I
two minus
minus
1.
1 that we can multiply directly. It is imaginary.
We cannot multiply directly. See, root a into root b can be written as root ab. Yes or no? Property is there.
Sir, there should not be two
Only for real
minus
numbers, sir.
negative integers in roots, sir.
If this property is not correct in this case. In this case, is it right or wrong? Root a, root b can be written root ab. I have applied this property here. Oh, obviously, to minus 1 into minus 1 plus 1. 1 can be written 1 square. It can
Sir,
final I
but
got 1.
Sir,
A and
inside
B
root
should be
we
positive,
can't
sir.
write negatives.
I nothing but negative only, no? Iota value I substituted. Yes.
So
Sir, we
maybe that
cannot multiply
rule
two
doesn't
negative
apply
numbers
for
into the
negative
square root.
numbers.
Yeah, see, absolutely right. Here, this root a into root b, we cannot apply for the negative values. It is for just positive value, positive real numbers. Root a into root b is equal to root ab for a comma b are positive real numbers.
Sir, we don't know that formula, what to take, sir, so that only we didn't say the reason.
Okay. So no problem. So right, is that clear? Try to do remaining questions. Okay, yourself. Even though I'll
Can you show
explain
fifth
you all
question?
the questions. Yes, Amma.
Can you show fifth question?
Yes.
Sir, those who want can leave, sir.
Yeah, you can leave. Already 8:57.
Thank you, sir.
Right, Amma.
Thank you.
Thank you, sir.
Fine.